Hi Mehdi, can you hear me? Great, great. So good evening. All right. So today we are going to go brief with how to connecting on Hive, and then we will talk about broadcast variables. All right. So let me open the slides. All right. Do you have any questions before we start? All right. All right. So while loading or saving data from Hive or to Hive, we can use Spark's inbuilt capabilities. And Spark provides you the out of the box ability to communicate with Hive. Okay. So so basically Spark has tried to make sure that you are able to read and write to all the systems which handle the data, and to do so, it has something called Spark SQL and also the Hive connectors. All right. So, what exactly is Hive? Hive is common structured data source on Hadoop. Okay. Hive just provides you a way to read data in a structured way. It does not provide you the editing facilities such as create a row, in update a row, or delete a row. Also, it does not provide you any other kind of update facility. And Hive can help you in accessing the data stored on HDFS or other storages. Okay. In very simple words, Hive started as something which can translate a plain text into a database table, and thus providing you the all capabilities to query this table such as SQL. And to connect to Hive, you can simply copy Hive site.xml to your Sparks conf and then create Hive context object as entry point and then start writing HQL. Let's try to take an example. All right. So let's follow the steps, and let me break it down to to two set of instructions. One is general introduction. This is just general introduction, and the okay, these are steps. Okay, so all right. Let me. Are you logged into the server? Let me also try to log into Spark 1. I'm right now at Hadoop 3. It doesn't matter where I am located. I can connect to Hive from anywhere. I'm hoping that. And so we have installed Spark here. All right. So let's see. We go to Spark folder, and inside conf. Okay, inside conf you don't see any Hive SQL right now, but we can copy our Hive configuration. Hive configuration is generally located at this place, so we just need to copy this Hive to the current folder. Now the current folder is inside Spark. Spark is what we downloaded, that zip file we downloaded and extracted. We have made the link to it called Spark. Or rename, you could also rename that to Spark, or you could leave it as such, it doesn't matter. For simplifying, we have made a link. Alright. Now you can see that we have copied the file from Hive to here. Okay. Let me also mention it somewhere here. Okay. This is what we did. Alright. Okay. So alright, this is what we did actually. We copied this into Spark's conf folder. Now all we need to do is essentially in on our PySpark model. Alright, let me just mention one more command here. Then we can say spark slash bin slash PySpark. Okay, and since we are already in this Spark folder, or we could also go back here and say spark bin PySpark. Alright. It tells you that Hive context is also available as SQL context. Okay. In case SQL context is not available to you, you can simply create this Hive context easily using Hive context object. Alright. Or let me just show you. So from PySpark.sql, we have imported a class called Hive context, and using the Hive context, we are creating the object of Hive context. Okay, you can see that we have passed the Spark context here. All right. Now, also in the meantime, let's take a look at what exactly is this table about. All right. So let's just try to take a look. Okay. So you can see that this table contains three columns: degree, name, and salary. Also, in case you're wondering how we reached here, you can log into Hue, and then after logging to Hue, you can go to Hive UI and then tables. All right. So the employee table is already there. You could try accessing some other table. Ouch. I have deleted the employee table. Okay, so default, there is a database called default. Yeah. So Jitender, yeah, you have missed a bit. So we are trying to connect to Hive. Okay, we are trying to connect to Hive from Spark. Hive is a kind of a database layer in top of HDFS or Hadoop, using which you can query your plain text file as if they are the database files. Now we are trying to connect with Hive. All right. So the steps which are involved is first you copy the Hive site.xml from your Hive etc Hive folder into the Sparks config folder, and then you understand the layout of your table. Okay. So right now we are trying to access this table called employee from our Spark, and this table has three columns: degree, name, and salary. Okay. So yes, the table exists. Now, after we have started our PySpark, what we have done is we have imported our Hive context and this particular Hive context class and created an object of this class called Hive context. Now, let's try to query this Hive context. All right. So here the connection is happening now. All right. Now inside rows, we have these two columns actually, not three columns. Right now we have just brought two columns from here. And then, um, so we can say for row in rows, okay, print row and we say dot name. Okay. So it says that, all right. So row is a data frame. All right. You can say row first, and that will give us the first row. You see that? We are able to get the data from the table. All right. If you want to see what are the functions available on rows, you could also do row. And all right. So you get this is data frame, which is kind of another kind of another kind of RDD. We will talk about data frames when we talk about Spark SQL, and you can collect all of the values like this into a local, okay, rows local variable, okay, and I on that for row in row local, you could say print row and name rows local, actually not row local. See that? So we were able to extract only the rows which we are interested in and only the columns which we are interested in. Sounds good to you? So this data is coming from Hive. Okay. Also, what we have just done is we have done rows local equals to rows dot collect, and on top of that we executed a command like this. All right. Is it clear to everyone? So what we did just now here. All right. You could also put where clause here, where clause name equals to say Sandeep. Okay. And then access only that data. Okay. So you can say simply collect, and then it will show you only those records. You see that? So now only the rows which have the name equals to Sandeep have come here. Sounds good to you? All right. Any questions at this point? Ishwar, Jitendra, Mehdi. All right. All right. Sometimes you need to load the JSON data, and that too you can use. So you can use this Hive context object to not only load the data from Hive, but also to load data from JSON. Okay, you can load the data from JSON or other formats using the same Hive context, the one which was used to connect to Hive. All right. Say for example, we have one data set containing user as the first name, and then this is another object. So user is defined by this object, while text is defined by plain string. So this user has said this, and this user's name is Holden, and his location is San Francisco. All right. So Mehdi's question is, I installed Spark and Hive, but I cannot connect to Hive from Spark. No, you don't need a JDBC driver. Okay. So all you require is, so do you have Hadoop already installed? Is your Hive working fine? Is your Hive is working fine? When you start the Hive command, you are able to see whatever is there, and also your Hive service is running fine. Are you able to access Hive service from the machine called Spark? Okay, so all you need is copy the Hive config into the config folder of your Spark. And then you can follow the same step what we have just talked. Okay. All right. Exactly the way we have done right now. So what we did is first we copied, you can see, etc/hive/conf/hive site. Basically, this hive site contains the information like where is the name node, where is the Hive service running, on what port, on what IP. So all of those details, if you have access in Spark Conf, then it's good. Okay. Or if you don't want to copy, you can simply link it. You can say ln minus s and link that file into Spark Conf. because here if you try to copy all of this all the time, what would happen is every time you modify hivesite.xml, you will also have to modify spark conf/hivesite.xml. Okay. All right. Mehdi, we can connect over this. Let me know if you get stuck again. We will try to resolve it. All right. Now moving ahead. So we can load the data from the tweets and then, okay. So for example, like here, what we have tried to do is we have tried to first load this JSON file into Hive context using Hive context. And once we have done this, what we are trying to do is we are creating a temporary table to represent tweets. Okay. Once we have created this temporary table called tweets, then it will act as if such kind of table exists in Hive, and you can query the tables very easily. Okay. All right. So that was about JSON. I think I have an example ready for JSON. All right. Right now, I don't have a JSON folder. Yeah, here it is. Or we could try seeing what is there in this. All right. So this is our the same similar to what we had discussed earlier. So this is stock something. All right. Let me put it in before we lose it. Let me put it at a common place. Copy from local. So I'm keeping all the data, whatever is required for you to experiment into into a common folder. Okay, say what was that, stocks, stock.json slash data slash spark. Okay, it's not there. Never mind. So we can actually live with this. So should we try to do this one? What was the name of this, stocks? Yeah, I think we can try this. All right, let's try to use Spark bin by Spark. All right. Hive context, how did we create? We created hive context like this. All right. And we could say, and the data which we are trying to access is in slash data slash spark. Okay, so we will try our best to see if we can query this JSON structure. All right, the JSON is quite big, and we need to format it to understand its structure. Okay, so what we will do is we will use JSON formatter to clear it. All right, now we can see things clearly. I hope it works. All right, so now instead of saying JSON file like this, we will try to mention the JSON file in this format. Okay, can somebody help me with this? hdfs colon slash slash hadoop 1 dot no big data dot com slash data slash spark slash stocks dot json. Okay, so let's see if it works. Unable. Okay, okay, looks like it's doing something. All right, looks like we have been successfully able to load our stocks. I think we should have just kept it stocks. Stocks equals to tweets. Okay, this is better. Okay, sounds good. Next is let's try to now query. Let's try to query. First, register the stocks as register temp table called stocks. And once we have registered that register temp table called stocks, okay, now we are taking the inspiration from this code and trying to query our data. So we can say stocks.sql and select, let's try to say ticker. Okay, two things. One is id, select underscore id dot $old comma ticker. Okay, These are the two columns we want from stocks. Sounds good? Let's see if it gives error or it runs. Looks like my network connection is gone. Hi, are you able to hear me? Because my network connection is gone. Hello? Ishwar, Gaurav, Jitendra, Mehndi, is my voice clear to you? Okay, okay. So we are trying to load a JSON structure using the same Hive context. Okay, and what is it that we are trying to do? First, we are loading it as a JSON file. Okay, it says Hive context is not available. Let's try to create the Hive context. Although there is already a context available to us like this. Okay, so we will use the similar structure like this. So we are saying create a Hive context. All right. Next is that we are trying to load JSON file from our HDFS. Okay, so it's loading the HDFS file into an RDD. It will create kind of a RDD. I'll show you what does it mean by. So it has created a data frame of our RDD. It has these columns and we can query these columns. Sounds interesting? You can see that there is an ID column, okay, and there is a ticker. So let's just try to access these two columns from our JSON, okay. So once that is done, let's register it as a temp table. So we have registered this data frame as temp table. Data frame is similar, a new form of RDD, which can be used across multiple other languages such as Spark R and Spark SQL. So we will talk about it a little later. Okay. Now we have registered the table. Now all we need to do is, okay. So did we register it as a table? All right. We just ran our SQL query. All right. We just ran our SQL query, right, in the same manner. We have to say here hive context dot SQL. Okay. Select from stocks. Yeah, this is the way we need to write. What does it say? Okay. All right. Looks like it has a problem in recognizing the dollar. Let's try to avoid dollar for time being. Okay. So yeah, we were able to get the results. All right. You can see that. all the tickers we have got in the form of SQL. All right. Now, so in the same fashion, you could access the other values as well. So if we want to, let me try to do it this way, if it works or not. Yeah, looks like it works. So we can say take 10. You see that? We are able to access our data in this fashion. Okay. Results dot take 10. Yeah, now it's correct. Alright, the only thing is it is trying to just mention this as, alright, let's try to do it this way. It's actually not accepting the dollar in this. Alright, that looks like a bug because our JSON has a dollar in the column name, and either we change that column name to something else, or we we make this accept our dollar. Alright, it's not accepting our dollar. Let's try. No, it's not. Alright, because this is the way you can access it. Alright, the further objects from this table, from this JSON structure. Let's try to access some other which has got spaces in it. Let's say we want to access profit margin in it. Oh, it's OID. It's OID. I'm not sure if it will work. Will it work? No. Mhm. Nope. So it's basically not accepting our column in that format. Alright. Let's try to see if profit margin works. Yeah, profit margin seems to work. Alright, see. I'm not sure. How do you generally escape the space in SQL? Anyone? Alright. So I'm facing a bit of problem in specifying the special character in select queries. So up to without anything, only the ticker one is working because that one does not have space. And here is the code for everyone. All right. You can try the same thing. I'm going to make the same code available as part of this. All right. So yeah. All right. So anyway, those are we can have a look at again. The more important aspect is that we were able to load the data from HDFS and the data in the form of JSON structure, and we were able to query the JSON structure from within Spark. All right. Sounds good to you? All right. Next is that you can connect to your databases using MySQL connector, and it's actually not very difficult. Just that few semantics in are being changed. Okay, few semantics are being changed, and okay, and basically, since at the Spark level there is a little bit migration going on, they are moving most of the things from the traditional SQL context to data frame. So there are a few things that may be a little deprecated. Okay, because Spark SQL was released few months back only. I mean, the data frame part was launched few months back only. Okay, I mean, at the time of launching this course, we did not have something called Spark R. Now there is a Spark R is part of the production. So we will also cover Spark R, although that was not in the part of the course curriculum. All right. Now coming back to the database part, all you need to do is while starting your PySpark or while start doing your Spark Summit, you could add your driver library path on the command line itself. Okay. And then once you have defined your driver library path, you can use that driver inside inside your code. Okay. So all you need to do is after you have started it, okay, let's just see. So from here we will need this. Okay. All right. I think this MySQL connector is not there. We'll have to make it somewhere. I don't think it is there. Let's see ls. Is it there? No. Find dot name asterisk dot jar. Okay, it's not there. Let me again make it available in HDFS so that we don't lose it. Okay, this is our MySQL connector, this one, and we can upload it. We can upload it in. I've downloaded this from Oracle's website. Alright, let me try to upload it in data folder inside Spark. I'm just keeping it at a consolidated place so that we don't lose it. Here we can say upload files, select files. Okay, so everything would be available in HDFS. All right. So okay, so it has been uploaded. If you want it, you just copy it to your whenever you're the trying Spark. So you can simply copy to local, the data Spark, and what is the file name? MySQL connector to this folder. All right, it has copied it. Next is that we can launch our Spark with this. Is this the file name correct? So it's a Java 5.1.36, 5.1.36. That's been correct. All right. Now let's try to execute these commands. All right. We will again revisit the SQL connection because of the changes in Spark. Recently, Spark had changed the Recently, Spark has introduced and moving almost everything to data frame. Data frame as a concept comes from Spark R or R. Basically, the RDD was essentially a data frame in terms of if you look at from the perspective of R. So as I told you earlier, most of the data-centric language have a representation of data. So starting with SQL, SQL had table as the representation of huge data, and Pig has again the data sets. Also, every job runs on some HDFS file, okay, or input split you can say. So input format, Hadoop input format was the input data for Hadoop. And in case of HBase, you have these big tables. So everywhere, the common thing you will notice is they all operate on a lot of data in the form of a big array. And each element of an array could be a complex object. Okay, so a huge array is the representation of almost everywhere. It's common across all the systems. While individual format of each element in this array could vary from one system to another. Okay, so data frame in R, data set in Pig, um, input format in HDFS. Everywhere the philosophy is almost the same. All right, so this we have done. Now let's try to execute this. If it doesn't work, we'll try it again while we discuss the. So what does it say? All right, not bad. Okay, so it says localhost and this. Since the database is not running on localhost, it's giving error. So we will change it to Hadoop 1 dot no big data.com. All right, so it has basically brought our data from SQL to here. Okay, so we are everywhere using the same SQL context if you see, and here we have used something called Hive context, and here we have SQL context. So using SQL context, we can load our data into this object. Okay, we can collect it locally, and it'll give us all the results in local. So it has brought the data from our database to here. Okay, Sounds good. Do you want me to show you where is this data actually? So what we are doing here is we are saying SQL context.load, source is JDBC, driver name, this is the class name which will vary from one database to another. In case of Oracle, the class name will be different, and in case of and the URL also might change. So if you have made JDBC connections earlier, you should get a fair bit of idea here. Okay, JDBC Java database connectivity. Okay, so here we are talking about get this particular table from a database called test. User is login, user is root, and password is blank. All right, I'll show you this. So if I start my MySQL client now and say use test and say select star from sales, select star from sales, you can see there is only one row. All right. If we say insert into sales and we say 200 and A2 and we say city as Bangalore and the state as KA and zip code is say 5600 and sale date is say 13/01/15. Okay. It says you have a syntax error in this. Check the manual for insert into. Have I forgotten my SQL? Alright, I think now it's correct. We had to put values in the syntax. So now you can see there are two rows. If we again say df.collect, now you see we have these two rows here. Okay, and also we can say local, we can assign it to local variable, and then for we can basically in this L rows will be a array of arrays. So we could say give me 0 and you will get this row, and under this we can further widget ID, and you can see we are able to query the data very smoothly. And this is in, we are talking to MySQL. Mandy, does this answer your doubts? So Gaurav's question is, you mentioned that data frame can be used in Spark R. So one can use both R, Python, Java in all three in one application. No, actually, you'll have to use either Java or Python in an application. But inside Java or Python, you can use R. The way we are calling SQL from our Python application right now, in the same way you could utilize the R. All right, was I able to answer, Gaurav? Very good question. Yeah. So basically, you could use Python and R together, Python, R, and SQL together in a single application, as well as you could use Java, R, and SQL in a single application, but you cannot use Python and Java right away. Python and Java together in a single application. All right, because the way when you launch something on the cluster, the behavior is different. All right, so all right, so Mandy, you can have a look at this. This should give you a clear picture, and from here you can say df.collect, or you could use map or reduce on top of df, or you could use, if you register df as a table, you can then do the select query on df. Okay, so this way we can load the data from the databases. Any questions at this point? All right. So we have been successfully able to load our data from databases, MySQL, from JSON, and JSON in local file, and in HDFS. Okay. And then we also were able to talk to Hive from here. We could also use, we were explaining to you how we generally access. So we showed you these syntax as how we accessed individual values. All right. We were able to read and write to HDFS. Okay. So Amazon S3 is something I'm not being able to give you a demo, but it is definitely possible. All right. So that was a huge session on various kinds of connectivities from Spark and to Spark. All right. So we loaded data from variety of sources and saved the data to variety of sources. Okay. So at this point, if you had to take a call and you had to decide whether to go for Spark or not, just based on data sets, you should be able to do so. Because as of today, as of today, Spark is able to connect to almost all the data sources available except for few non-proprietary ones. All right, good, good. Let's move on. All right, let's try to understand the few of the advanced constructs of programming with Spark. All right, is the session being recorded? Yes. All right, so do you remember how we used to access how do we used to share the data across all the MapReduce jobs? Anyone? So do you remember how we used to access share the data across the whole Hadoop cluster? All right. So we used to have something called distributed cache, but it was heavily limited. Okay. So so first of all, why do we need shared variables, and what's the purpose of it? So mostly when you are running your program on anywhere, any cluster, anywhere, you need some amount of data, some amount of cache which is basically available to you then and there. Or going back to one of the examples, okay. So here when we try to execute the map function, so all the local variables of the function as well as all the global variables referred by that particular map function are also shipped to all the nodes. So that is also data sharing. That's also sharing variables. Okay. So whenever we said define map, and we define your function, and then we said execute this function as mapper, all the variables inside that function were copied to all the nodes, because the way function get copied to or function gets shipped is everything inside a function as well as everything the function pointers function variables are referring to, the global variables, all of those will be shipped to the network. Okay. but the changes to but the changes to these variables are not communicated back from any of the nodes. Okay, so after starting off the map, changes to the variable on the driver does not impact the worker. So now, if you change the variable which you have shipped to all the nodes, or the changes which all the nodes have done to those variables inside the function, it wouldn't come back, or it will never be communicated, because all these variables are local copy become local copy on that particular node. Okay. So to communicate to all the nodes in your cluster, to send some data or to gather the data from all the nodes in the cluster, you use these shared variables. So there are two kinds of shared variables. One is called accumulator. Accumulator accumulates the data. Accumulator aggregates the data, and broadcast variable efficiently distribute large large values. Okay, so accumulator bring data from all the nodes to your driver node, and broadcast variable take the data from your driver node and make a copy on all the nodes. All right. All right. Now here are a few questions for you. An operator is cumulative if A operator B operator C is equal to A operator B. So can you match the following two sets quickly? Anyone? I'll answer your question, Ishwar. Anyone?